Okay, so guys, in this video we have to find the Taylor series for natural log of x at a is equal to 2. And in the previous video I forgot to mention one thing, that this point a is equal to 2 is also known as the neighborhood point. Now let's start by taking the zeros, first, second, third and the fourth derivative of this function. Okay, so the zeroth derivative of course will actually be the same thing, natural log of x. The first derivative, the derivative of natural log of x, is 1 divided by x, which can be written as x power negative 1. The second derivative of this thing, x minus 1, would be, the power will be separated, then the function minus 1 gives us negative 2. Then the third derivative of this thing right over here, so negative 1 will be as it is, then the negative 2, the power will be separated, then the function power minus 1, minus 2 minus 1 gives us negative 3, and this can be written as 2x power negative 3. And for the fourth derivative, I think up to 4 terms it is fine. We do not have to take many more terms. So for this fourth derivative, first of all 2 will be as it is, then the power function x power minus 1, minus 3 minus 1 gives us negative 4. So this can be written as negative 3 multiplied by 2 gives us negative 6x power negative 4. Okay, so now let's put this thing into the formula, and let's put the value of x, 2, divided by n factorial. So what is n? These things right over here. So for the zeroth derivative, it was natural log of 2, because the value of x given to us is 2. And also of course we have to divide it by the factorial. So n factorial, for our case, this case, the n is 0, so 0 factorial. Then for the first derivative, we have to put in over here. Then for this case right over here, we have x power negative 1. We can write it as 2. Okay, so x is 2. Then minus 1 divided by n factorial. What is n? 1. So 1 factorial. Okay, now this can be written as 1 factorial multiplied by, this 2 can be reciprocated. So we will have 2 power 1 and we will be left with the 1 in the numerator. Okay, so now we have negative 1. The value of x given to us is 2 power negative 2 divided by the nth factorial. What is n? 2. So 2 factorial. So this can be simplified as negative 1 will be as it is, 2 factorial. 2 factorial is actually equal to 2 multiplied by 2 power negative 2 can be reciprocated. So then it will become positive. So we will have 2 power 2. For the third derivative, we have 2x power negative 3. So 2 will be as it is. X is 2 negative 3 divided by the nth factorial. N is 3. So 3 factorial. So we can rewrite this as 2 divided by 3 factorial is actually equal to 6. So 3 factorial is basically equal to 3 multiplied by 2 multiplied by 1. So we will have 3 multiplied by 2 multiplied by 1. The 2 will be cancelled. If you see, the 2 over here will be cancelled by this 2 right over here. So we will be left with 3 multiplied by 1 gives us 3 multiplied by this 2 will be reciprocated. So we will have 2 cube and we will have 1 over here. And for the fourth and the final term, we have negative 6. X power negative 4 can be written as 2 power negative 4 divided by the nth factorial. N is 4. So we have 4 factorial. Now 4 factorial is actually equal to 4 times 3 times 2 times 1. So if you see, we have 6 right over here. So 3 multiplied by 2 is 6. So these will be cancelled and we will be left with 4 multiplied by 1 gives us 4. So we can rewrite this thing as, so 6 is cancelled and we are left with a negative 1. So we have negative 1 divided by 4 multiplied by, this thing will be reciprocated. So we will have 2 power 4. Okay, so if you see, we have a very definite pattern over here. We have 0 factorial, then we have first factorial, then we have second factorial, we have third factorial, fourth factorial, and of course the powers, this thing right over here is also following a very definite pattern. First power, then the second power, then the third power, then the fourth power. Okay, so now we can put these things into the Taylor series. So this is the Taylor series, and now we can put the values. So fa, the very first value, the value at the zeroth derivative right over here, is natural log of 2. So this can be written as natural log of 2. So you have natural log of 2 plus the value of the first derivative is 1 divided by 1 multiplied by 2. So we can rewrite this thing as divided by 2, and then x minus a. What is a? It is 2. So x minus 2. Then for the second term, we have negative. This is the second term. So we have negative 1 divided by 2 times 2 squared, x minus a squared. So x minus 2 squared. Plus f third derivative is this thing right over here. So we have 1 divided by 3 multiplied by 2 power 3 x minus a cube. So a is 2, so x minus 2 cube plus, oh sorry, it is actually negative, right? So we have negative 1 divided by 4 times 2 multiplied by 4 x minus a power 4. So x minus, instead of a we have 2, 4 plus dot dot dot, this goes on till infinity. Now we have the first 5 non-zero terms of the Taylor series. Now we can rewrite this thing in the sigma notation. So this thing is by itself, so we can just rewrite it as it is. Plus, if we look over here, we have a definite pattern. We have 1 square, then we have 2 square, 2 cube, 2, 4. So we can rewrite this thing by taking into the consideration of the n values. Okay, so sigma actually starts from n is equal to 1, goes on till infinity. Okay, so it is starting from the first derivative. Okay, when we were taking the first derivative, so this term was starting from the first derivative, and then the terms were being added. So from the n is equal to 1, then goes on till infinity. Okay, so we have a positive sign, then we have a negative sign, we have a positive sign, and then we have a negative sign, and this pattern follows till infinity, right? So if we have a negative sign, we can rewrite it as negative 1 power n minus 1. For example, if you have n 1, so at n is equal to 1, 1 minus 1 gives us 0, right? Minus 1 power 0 will actually be equal to, of course, 1. So it will be positive, right? See, the first term right over here was having a positive sign. And then for the second term, we have negative 1. We have to put in the value of n, right? For the second term, n is 2. So we can write 2 minus 1 is 1. Then the value of this thing will be negative 1. See, the second derivative was having a negative sign. Okay, so you have to rewrite this thing in this format, divided by, if you see, what do we have over here? So if you see, we have 1, 2, 3, 4. 0 factorial, so we have 0, 1, 2, 3. Of course, we are taking the derivative with respect to the n values which were given to us. So we can rewrite n multiplied by, if you see, we have 2. So 2 power 1, 2 power 2, 2 power 3, 2 power 4. So we can write 2 power n. And then x minus 2 power n. Okay, so this is the final Taylor series for this function.